Alrighty. Go ahead, medium today. Minimum number of flips to make a binary string alternating. You're given a binary string S. You're allowed to perform two types of operations on the string in any sequence. Type 1, remove the character at the start of the string and append it to the end of the string. Okay. Type 2, pick any character in S and flip its value. If its value is 0, it becomes 1 and vice versa. Any character. Return the minimum number of type 2 operations you need to perform such that S becomes alternating. Minimum number of type 2. The string is called alternating if no two adjacent characters are equal. Okay. For example, 0, 1, 0 and 1, 0, 1, 0 are alternating. 0, 1, 0, 0 is not. Well, okay. What does this mean exactly? 1, 1, 1, 0, 0, 0. So, I mean, you can flip this 0, this 1 to a 0, and this 0 to a 1 without really using any type 1. Type 1 is just like moving, kind of cycling front to back. Although if you did cycle front to back, would it have helped at all? We've gone 1, 1, 0, 0, 0, 1. Still need to flip. Let me double check. See, 1, 1, 1, 0, 0, 0. If cycle becomes 1, 1, 0, 0, 0, 1. So you'd still need to make this a 1, and this is, make this a 1, and you make this a 0, so still 2. So if I were to consider if it's an even, so if it's even length, right? Even length, it'll be like 1, 0, 1, 0, 1, 0, or like 0, 1, 0. So the ends are different, and end values are different. And if it's odd length, then the alternation would mean that the end values are the same. Okay. End values are different, end values are the same. I wonder if I can just do some sort of simple calculation for every index. For every index, like find the least number of alternation, least number of type 2 flips that you need to do up to that index in order for it to be alternating both for like 0, 1, 0, 1 versus 1, 0, 1, 0. And then do the same thing backwards up to a certain index. The number of flips you need to do after that, or after some certain index, the number of flips to make a certain version of alternation. and then you find like the minimum of like the pre and the post, so that the post could be like the pre, like the post. If you do type 1 on the pre for the index, then the pre becomes the post. I think that it might work. It might be a little slow. I assume this is pretty big, right? 10 to the 5th. Yeah, so it has to be linear. I mean, I think what I'm thinking about is doing 2 passes, 3 passes. Let me think about this. Let's say it was all ones. No, let's say it's like that. What's the, if I go all the way to the end, what's the least number of flips to get 1, 0? So the least number of flips to get it to be 1, 0, 1, 0, 1, 0 is going to be 1, 2 flips. And then the number of flips to make it 0, 1, 0, 1, 0, 1, 1, 2, 1, 2. Oh my god. Can't visualize. 1, 2, 3, 4. Yeah, it's 4 flips. I guess it has to be complementary. It has to add up to the sum. It has to add up to the length of the thing because these are strictly opposite. Okay. So I can just do one of the two, and that would give me the other set. So I could do a count for every index. For every index, the number of flips to get to 0, 1, like 1, 0, 1, 0 for that index. Okay. Every index. For every index in range n, I'll assume it's going to start with 1, 1, 0, 1, 0, 1, 0. So current plus equals 1 if let's say compare value is 1. If alright. Trying to think of how to do this fancy. I wonder how long it take me to convert the string to a binary array. Whatever. Okay. Plus 1 if s let's just convert to binary array. S equals list, I think the syntax is list map to int s. I think that's the syntax. Yeah, so it's mapping to integers every character in this string array, basically, in the character array that is the string, and then converting the kind of iterator there to a list. Okay, so for every index in range n, let's say current. I think maybe I can even do something like flips, and maybe it should be 0. That equals 0. If s at index equals, no, actually I'll just compare index mod 2, so it's even. If it's starting index 0, 0 mod 2, 0. So if it is equal to 0 or if it equals 1 on the first index, then flips current plus equals 1, and then flips appends the current. Guess I could just I can do something like current plus equals s at index XOR index mod 2, because here 0, 0 increments and 1, 1 increments. So if 0 and 0 and 0 XOR, I guess XOR 0s XOR 0s can be 0, 1 XOR 0s, 0 as well. So maybe it's supposed to be current plus equals asset index 1 minus asset index XOR index mod 2. Or I could just do it the other way. It's fine. I think exclusive OR is this operator. It's the caret, right? Okay. This is actually going to compare to 1, 0, 1, 0. I don't think that worked. Definitely don't think that worked. I wonder if I should need to make this parentheses. No, same deal. Actually, this one looked like it might have worked. 0, 1, 2, 3. Actually, this might have worked. So let's try and convert to 0, 1, 0, 1. So I need to do 1 here, does need to do here, so it's just 1 still, 2, then needs to do that 1, 3. So if it goes 0, 1, 0, 1, so it'd be 1, 1, 2, 2. Oh god. 0, that's 1. 1's fine. 1 here's, that's 2. So that should be 0. There should be a 1, so that's 3. That's the 3, that's 4. Okay, so I think that's fine. So I have the array that is the number of flips necessary to make it 0, 1, 0, 1 to a certain index up to a certain index. So now it's just combining it with the type 1 operation. Because in theory, if you didn't do type 1 operation, then you would just return the last element of flips, or the complement of that, n minus that last element. It's either like 2 or 4 if it was like flipping this thing to 0, 1, 0, 1, 0, 1, or 1, 0, 1, 0, 1, 0. So how do you incorporate finding a middle section? Am I making this too simple? Have I made it too simple? Like, I'm assuming that you just need to do the type 1 operation once. There's really no benefit of doing multiple times. Or you do the type 1 operation for a certain index, pretty much. Like, you cause the string to cycle through to the end, cycle through up to a certain index, and it's not beneficial to try to do it multiple times. I'm pretty sure. I'm having a hard time imagining why you'd have to do multiple indices where you're cycling with the type 1. Like example 1, cycling it didn't do anything. See if I can cycle it twice. Again, that really doesn't do anything. Still would change it. Change this one to 1, that one to a 0. So when is it beneficial? Because if it's already in the correct spots, like if it's an even number, actually I don't think cycling with an even number even matters, right? Type 1, when would you ever want to do an even cycle? So let's say yeah, I'm pretty sure the type 1 operation is only beneficial for an odd length string. Because with an odd length string, I can maybe imagine something like this, right? Cycle the 1 to become 1, 1, 0, or 1, 0, 1. Okay. So I think here I can say if the length of the string is even, then return the minimum of the last value in flips or n minus the last value in flips. Okay. And then the last little bit is how do you figure out for odd? For an odd length string, leaf flips tries to find it for leading 0. 0, 1, 0, 1, 0. I think so. However you divide it, you're dividing, there'll be an odd and even. An odd and even wherever you choose to split up the two. 0, 1, 0, 1, 0, 1, 0, 1, 0. So if I bring this back, comes 1, 0, 0, 1, 0. If I bring that back, it becomes 0, 1, 0, 0, 1. So don't bring any back doesn't work. Well, it doesn't need any work. Hmm. 0, all zeros. 0, 1, 0, 1, 0. Okay, what if it was actually correct? So, for instance, 0, 1, 0, 1, 0, 1, we want to move the first two. We want to move the first two. So for the flips for this one, it would be, you would need to flip these three. So the array would here be 0, 0, 1, 2, 3. 0, 0, 1, 2, 3. So it would be each index from index 0 to n would need to compare. What do I need to compare? Yeah, I'm getting so much worse. I feel like I'm in molasses, my train of thoughts. So from the index to the end, from the index to the end, here would be 3 minus 0. So that's the number of flips in order to make it a certain set. So it'd be n. This thing right here is n minus flips at index. N minus flips at index. Right. Yeah, the end it flips at index, so here it'd be 3. It'd be 3 to get it to be what? I think I'm doing this. It would be 3 to get to here. So that aligns with 0, 1, 0, 1, 0. And then from here to here, it's also 3. If I move this 0 back to the end and get 1, 1, 0, 1, 0. So it would take 3 to get to come 0, 1, 0, 1. And it should take 0. N minus flips index plus zero, 0, 0, 1, 1, 0, 1. So if I'm making a certain thing become starting with, it's not always starting with 0. Starting at whatever the sequence would be if it started at 0. Whatever the sequence would be if it started at 0. So whatever the sequence would be if it ended at 0. N minus flips at index is the number of flips it would take to go from the index to the end, where the end is 0. And then if you cycle the stuff before the index, then the calculation would be that part needs to be complemented because you want that part to be 1. So it should be something like n minus flips at index plus the complement of it, the complement of the start, plus like I minus flips at I. So this is one answer, and then the other answer is just n minus this. Okay, well, let's try it. So let's say answer equals 0 for every index in range n. Let's say post is equal to n minus flips at I. Pre is going to be I minus flips at I. And then answer equals minimum of answer. I guess I should start infinity then. Minimum of answer. I think this should be pre plus post. Or it could be n minus pre minus post. Oh my god, if this works. Doesn't work. -2. Alright, alright. Well, it kind of worked. But -2 is questionable. It must be this. N minus pre minus post. Yeah. Alright, let's go ahead and just read out flips. Zero, zero, zero. Right, right. I don't think it covers the initial case. The initial case should be no cycling. So no cycling should be flips at the end. No, it could be that or n minus flips of that. Yeah, I think this is right. Gosh dang it. Suckering succotash. Alright, I think I need it. Well, I already did print flips is 0, 0, 0. Minimum of flips at the end, which should be 0 versus n minus flips. And there's 3, I think. Oh, I see. So somehow it's getting negatives, and negatives are making it remove the actual valid answer 0. So n minus flips at I seems reasonable. That'd be 3 minus 0. Or maybe not reasonable. is n minus flips I. N minus flips I minus flips I. N minus flips I should give me I wonder if this should be flips at n minus flips at I. N minus flips at I. I think maybe that might be right. Flips at n. I think this should be just flips at -1. Oh my god. Where does this not work? Oh gosh. Alright, I'm running on fumes. Is this odd? Yeah, so do. Okay, so what's the ideal split here? Ideal split should be so there's total 6 flips in order to make the 0, 1, 0, 1, 0, 1, 0, 1. There's basically 6 flips. So the flips are, that's the first flip, second flip, third flip, fifth, sixth, seventh. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. 4, 5, 6. So there should be 6 total flips. I think that was what was given. Yep. So given that there's 6 total flips, maybe I can just print out the answers for each value of n. So if it was 0, then you'd need 6 flips in order for this to get to ending in 0. So we'd start in 1 here, 1, 0, 1, 0, this 1 is off, this 0 is off, that 1's off. So 0, 1, 0, 1, 0, 1, no. 0, 1, 0, so that's 3, 1, 0, oh my god. So this thing would be 0, 1, 0. So that's 3. That's fine. It's fine. 4, 5, 6. Yeah, so those 6. And then if this is 0, then it needs to go back here. And that makes it 7. How many characters is this? 3, 6, 9, 10, 11. The closest was this 8. Honestly, that should be the correct one. So here should be 0, 1, 0, 1, 0, 0, 1, 0. That's 2, 3, 4, 5, 6. Oh Lord. Affected is 2. You keep 0, 1, 0. That should be a 1. That should be a 0. So it's 2 already. It must be doing something that I'm not thinking of here. Oh my god. So sleepy. Oh. What make this better? It would be here actually, right? If you made that right there, it'd be 1001, 101. At that point, you just need to change these two to 1010. Yeah, those two plus this one. No, wait, that one's not even there. Oh, wait. I made arbitrary spacing, so yes, that should be there. So 1, 2. There should be a third one here. But the test result says I can do this in 2. Oof. Can I do in 2? If I take it up there, So if I split it up here, 0, 1, 1, 0, 1. So this 0, 1 oof. What if I kept the last one 0, 1 and changed everything else? 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1. So it would need to change 1, 2, 3, 4. Huh. How did this thing even change 2 to get this to be alternating? Like these two. So 0, 1, 0. Yeah, there's no way you can keep it, right? 0, 1, 0. Hmm. 0, 0, 0, 1, 2, 3, 3, 3, 4, 5, 6. So if I move this thing here to the end, this thing over this thing to this thing ends with a 0. It's supposed to always end with a 0. And then this thing should be the rest. The complement, this should be the rest. So it should be 3 minus that. Pre plus post, or n minus pre minus post is going to be, this is the number of flips to make it to the n with the 0. And then because this n with the 0, then you want to flip it to a 1 at the end. So you have a 1 at the end, 1 at the front basically. It should be I minus flip to I. Wonder if I'm doing something wrong with the inclusion. I pre plus post. Yeah, this should be end with 0. And if I just do flip to I, it would go up to the ith index starting at 0. So then I would need to do ni minus flip to I. Flip to I is inclusive of the index. Should this be I minus 1 minus flip to I? I minus 1. Alright. I am way too sleepy tonight.